Okay, so let's start. So yesterday we were discussing about the test design techniques, in which one equivalent partitioning we have covered. So today we will start with the boundary value analysis. This technique focus on the boundary as a greater than number of errors occurs at the boundaries of the input domain. It also basically deals with the range. If any condition where range is specified, there also you can use boundary value analysis. If you try to understand this concept with the help of an example, check the salary of an employee whose maximum salary is 20,000 and minimum is 10,000. So you want to write a test case where you have to check the salary of an employee. Minimum should be 10,000 and maximum should be 20,000. So a list will be generated for those employees who has the salary minimum 10,000 and maximum 20,000. So what will be the boundary condition? How we will decide the boundary? The boundary condition can be decided when we think about the negative scenario. What is the positive range? 10,000 to 20,000. Between this, if I enter the salary between this range, then I can see the employee salary details. But what if the range is this one, triple nine, sorry, 9,999, that is less than 10,000. And what is if it is greater than 20,000, like 20,001? These two data are the positive scenario, and this is the negative scenario. Minimum and maximum, we have a range. So we also have to test the application below the minimum range and above the maximum range. So in this scenario, we can have four type of test cases. Five type of test cases can be done. One is the positive testing where I will enter 10,000. Second will be I will be enter 20,000. Third will be I will enter any data that lies between 10,000 to 20,000. Then there will be negative testing where I will enter a value that is 9,999, and in one I will enter the data that is 20,001 rupees. So for this scenario, you can write five test cases with five different test data, or you can write only one test case and you can mention test this particular test case with five different set of data. So that set of data also you have to mention. Same test case you will test with five different set of data. So this is how we decide the boundary value. Once you start thinking about the negative scenario, then automatically that part you will start understanding. Here we are dealing with the range. So whenever there is a range, so go with the boundary value analysis techniques. Equivalent partitioning. These two techniques you can follow. Okay. Apart from these two, there are more techniques also. That is, one is the decision table. One second. Yes. So next is the decision table technique. Decision table technique is also known as cause effect table. Means there will be a cause and there will be a effect of that. This test technique is appropriate for functionalities which has logical relationships between input and output. You can consider an example of yesterday I have given you an example of username and password. That doesn't comes under any range. So that doesn't comes under equivalent partitioning or decision table making. Sorry, boundary value analysis. That comes under decision table, cause effect table technique. In decision table technique, we deal with combinations of input. To identify the test cases with decision table, we consider conditions and actions. We take conditions as input and actions as output. How? Uh, Only one scenario to test the login functionality of an application. This is a scenario for which we have to write test case. One positive test case will be you have entered username and password and you are able to log in. This is a positive scenario, one test case. But what about the negative scenario? What are the different combinations of username and password that you can enter to test the application? One can be, as I said yesterday, username is correct, password is wrong. Username is wrong, password is correct. Username and password both are incorrect. So this is the cause. The cause is your the condition is your input, that is the data, username and password. And effect, like when you will enter correct username and password, then what will happen? That is your output. You will be able to log into the application. If you enter incorrect username and correct password, so what will be the output? You will display a message. The application will display a message. Username is incorrect. This is the output. If both are incorrect, then username and password are incorrect. This message as an output I should get from the application. So this example is based on decision table technique, cause and effect. There will be a cause, there will be a condition, and for that there will be an effect, that is the output. So this username login functionality comes under decision table technique, where we have to think about the different set of data. We always think about the negative scenario whenever we have to write test case for any scenario. Always think about the negative scenario. If there is a range, if it is talking about any number, any range, you now aware of like how you will decide the positive data, negative data, and based on that you can write your test case. Similarly, decision table also now you can understand. There will be a cause and it will have an effect. Like that's it's simple. If you are doing something, then for that there will be a reaction. Just 1 second. Okay, so there will be a cause and there will be an effect. So this the user login functionality comes under decision table. Next one is the state transition testing. State transition technique. This is an important concept. Using state transition technique, we pick test cases from an application where we need to test different system transitions. We can apply this when an application gives a different output for the same input, depending on what has happened on the earlier state. If I give you an example, ATM machine. Let's suppose initially you have an account and that is 10,000 rupees. You have gone to the ATM and you have withdrawn 5,000 rupees. This is your first input. You have entered 5,000 rupees and on the output side, you got 5,000 rupees from the ATM. Or let's take it as 3,000 rupees. First time you entered 3,000 rupees, and as an output you got from the ATM 3,000 rupees. Now again, in the second time you entered 3,000 rupees, and the ATM has given you 3,000 rupees. So 6,000 rupees has been withdrawn. Third time again you have entered 3,000 rupees, that is again withdrawn. Fourth time again you entered 3,000 rupees. In this time, the ATM will show you insufficient balance. Input is same, 3,000, 3,000, 3,000, 3,000. But for the first three times it worked because the balance was 10,000 rupees. So the output was you got the money. But the fourth time the output is different. It is showing insufficient balance. So this is what here it is talking about. For the same input, output will be different. Input will be same, but output will be different. Depending on what happened on the earlier state. Like previously what happened, based on that output will change. So previously during the third time, 9,000 rupees you have already taken out. So only 1,000 rupees has left. So that is why on the fourth time output will be different. So the output is dependent on the previous transition. So if there is something, if any scenario, any test case that deals with state transition, like the next activity is dependent on the previous activity, that comes under state transition technique. There are different examples: traffic lights, vending machines. Vending machine dispenses product when the proper combination of coins is deposited. Traffic light will change sequence when cars are moving and waiting. ATM machine is also an example. So this is comes under state transition technique. So we have basically four generic type of testing technique that we follow for write our test cases. Okay, so every scenario cannot come under these four techniques. If something comes, now you understand about this four technique. If some scenario, if you read and if you connect with all any of this four technique, then you can follow this one and you can write your test cases based on that. If any scenario doesn't connect with any of these four, then based on your understanding, your logical skill, you have to use for writing test cases. Okay. And all these four techniques comes under black box testing. There are two types of testing: black box and white box. These four techniques that we have discussed: equivalent partitioning, boundary value analysis, decision table, state transition techniques, all these four comes under black box. This technique are widely used as best practice in the industry. Black box test design technique are used Black box test design technique are used to pick the test cases in a systematic manner. By using these techniques, we could save a lot of testing time and get the good test coverage. So all these four techniques that we have discussed, that comes under black box testing. Black box test design technique. This has four category, four types, and we have discussed about all these four. In interview, you can expect question: what is black box and white box testing? So you have to explain them. First, you have to give the definition, then you have to discuss about these four techniques of black box. Then you have to discuss about white box technique. So what is white box testing? So if you see this example, based on that, it is created. There will be an input, and for that, there will be an output. So let's discuss about white box. White box testing is a software testing technique that is based on application, internal code structure. In white box testing, an internal perspective of the system as well as programming skills are used to design test cases. This technique usually is done at the unit level. So if you read this definition again, then you will understand it is talking about programming and it is talking about unit level. And you know, like who do the unit testing? Developers. So white box testing is done by developers, not by testers. This is the base one difference. Black box testing is done by testing team and white box testing is done by development team, where programming skills is required and it is basically done at the unit level. That means white box testing comes under the unit testing. In this testing, tester must have the knowledge of internal structure, design, code of application under test to verify input output flow and improve the design security and usability. If any tester has the knowledge, then only he can do it. Otherwise, developers basically do. And this is the process: gathering requirement, test plan creation, test case test creation, defect reporting, text execution, defect reporting. This is the process of white box testing. Same process that we have discussed in STLC. Types of white box testing: unit testing and integration testing. Yesterday we have discussed about labels of testing. Unit one was the unit and second one was the integration. That too comes under white box testing. Unit testing, we do execution testing, operation. These are the different types of testing we do. And integration testing, this we have already discussed. What happens in integration testing? So we no need to bother about this part. Only thing we should know like what is unit testing and what is integration testing. And these two comes under white box testing. The rest of the two, system testing and user acceptance testing, that comes under black box testing. So yesterday we have discussed about four labels. The first two labels comes under white box, that is done by mostly done by the developers, and the black box testing, it is done by the testers. And here you can see the differences. It is a way of software testing in which the internal structure or the program of the code is hidden and nothing is known about it. Implementation of code is not needed for black box testing. Like whoever is doing black box testing, he or she doesn't have the knowledge of, like it is not required that he or she has the knowledge of coding or any programming. That is why this part comes under testing. And here coding implementation is necessary. Like the person should have the knowledge of programming skills, programming knowledge, everything he should have. So that is why this part comes under. If you see, it is mostly done by software tester and it is mostly done by software developers. This part comes under development and this part comes under testing. No knowledge of implementation is needed. Here the knowledge of implementation is required. It can be referred as outer or external software testing. It is referred as inner or internal software testing. Where, because here we are testing the coding part that we are writing. That is why it is known as internal software testing. And as a testing, we are just testing the application. Internally, how the code is implemented, we are not testing. We are just testing the functionality. So that is why it is known as external software testing. External, we are just testing the external part in black box. And in white box, we are testing internal part, the coding part. It is a functional test. It is a structural test. No knowledge of programming is required. Here, programming knowledge is mandatory. And rest of this testing can be initiated on the basis of requirement specification document, and this testing can be initiated on the design details design document. It is a behavior testing. It is a logical testing. Logic testing means the programming part. Behavior testing is the functionality part. So these are some differences that you can say in interview if any interviewer is asked. The important one is it is done by tester and developers and coding knowledge is required. It is here not required. Unit testing and integration testing comes under white box. System testing and acceptance testing comes under black box. These are the major difference between white box and black box testing. Okay. Anything to discuss? Anything to ask? Okay. If not, then let's discuss about the defect life cycle. We we have the knowledge of defects, but what is a defect life cycle? When you create a defect, then it goes through a several stages. So that is basically known as defect life cycle. These are the different states of a defect. So when you found a defect, when a tester finds a defect, he create a defect. So that time the status will be new. That time the status of the defect will be new. Once the bug is posted by the tester, the lead of the tester approves the bug and assigns the bug to the development team. When the bug is assigned to the development team, then the status will be changed to assigned. When developer will start analyzing the defect, then he will change the status from assigned to open. And when developer will fix the defect, then he will change the status to fixed. And when developer, once he has fixed, he will assign back the defect to the tester. So there the status will be pending retest. Once the defect is fixed, developer gives a particular code of retesting code to the tester. So that is why the status will be on pending status. Once testing tester will start retesting, then he will change the status to retest. The tester retests the bug after it got fixed by the developer. If there is no bug detected in the software, like if that defect is fixed, then the bug is fixed and the status changed to verified. If the bug is fixed, then the status will be verified. And if during retesting, if it is found like the defect is still not fixed, still the same issue is coming, then again tester will reopen the same and it will make the defect status as reopen. Then when it is reopened, so what will happen? From here again, same process will start after open. From here, the same process will start to this. If it is reopened, then again developer will fix, then again it will go to pending retest, then again testing team will retest. If it is fixed, then it will be verified. And if it is not, then again the same process will repeat. But let's suppose it is fixed, then the tester will close the bug. Then he will change the defect to the closed state, like it is fixed, it is closed. So these are the defect life cycles. There are more cycles like duplicate. Let's suppose you and your colleague both are working. Uh, your colleague has already raised the defect, and by a day after tomorrow you are finding the same defect. You have not you have no idea about that. The defect is already found and it is already created, and you have also created the same defect. So in that case, your defect will be marked as duplicate, and you have to reject. Your defect will be rejected. First, it will be marked as duplicate, and then it will be rejected. There is one more scenario when your defect can be rejected. You have created the defect, you have assigned to the developer. Developer is analyzing the defect, and he found like this is not a defect. You have you have some you haven't understand the functionality clearly, and you have raised the defect. But this is actually not a defect. This is how the functionality works. Okay. So your test lead will also see, and if it is found, yes, this is the correct functionality, it is not a defect, then your defect will be rejected by the developer. There is one more cycle that is deferred. What is deferred? Let's suppose you have raised a defect in this sprint, and that defect has is minor, like it is not very high priority. It can be fixed in the next sprint also. It is not a priority thing to fix right now only. In that case, your defect will be marked as deferred and it will be picked in the next sprint. If it is a minor bug, simple normal defect that is not affecting anything, so that will be marked as deferred. And it can be, if there is a deadline problem like time is not available, so it can be picked in the next sprint. Till then it will be marked as deferred. And then there is a status called not a bug. If it doesn't affect the functionality of the application, then the status assigned to a bug is not a bug. So this is same as this one. You cannot consider this also. It is not required. So these are the different defect life cycle from start to end, how it goes on, how the status gets changed. So this is how, and these are the number of defect status. Same thing I have explained in the help of a diagram, and same thing I have written, same thing is written over here also. Bug severity, bug priority, I have already discussed. Okay. So anything, anyone, any defect, anything to discuss? If not, then let's move on to the next topic. There are some different types of testings. We have seen functional testing, regression testing. Now we will see some other types of testing. One of them is ad hoc testing. Ad hoc testing is an unplanned activity which does not follow any formal process like requirement document, test plan, test cases, etc. It comes under black box testing method that focuses on both logical and illogical scenarios. Ad hoc testing uncovers the bug that we would not have found when we followed the formal process. Basically, ad hoc testing comes at any stage. One of the example, if I give you, everything is going on, development and testing activity, everything is going on, but due to sudden some development activity, the application functionality is getting affected. Or let's suppose the server is down, or due to the wrong development has happened, and we have found like the application is not behaving as it should behave. So in that case, what will happen? Development team will remove the changes that they have done due to which this problem is happening. So once they will remove that changes due to which the problem is happening, then immediately the testing team has to do an ad hoc testing just to ensure now the functionality is working fine, all sections are working fine, there is no issue due to that wrong development. So this is ad hoc testing. In ad hoc testing, you don't need to follow any test case. Based on your knowledge, you have to test. Like you know what can happen in add to cart section, what can happen in wish list, what can happen when you search a product. So based on your knowledge, you have to randomly do the testing of each and every section. You don't need to follow any test case. So basically, ad hoc testing is done by those testers who has the good knowledge of application. Any junior or any fresher cannot do this. Who only that tester can do who has good knowledge, who is working on the application since a very long time. Only he or she has the knowledge of the application, and they only can do this ad hoc testing. Testers should have a
So
good
all these tests are performed in the industry.
yes, ad hoc testing we do. Testers should have a good understanding of the product because ad hoc testing completely depends on the improvisation and intuitions. You like if you are new to the project, then you cannot do this because you do not have more knowledge of application. So you are not the right person to do this. Any experienced person who is already working in the project since 2 years, 3 years, he can do it perfectly because he has the end-to-end knowledge of the application. And there are different types of ad hoc testing also. One is buddy testing. In this testing, two teammates work execute the test case. Ideally, a developer and tester will be testing the same model. It usually takes place after unit testing. This helps the developer to understand the testing process, which in turn makes better code. Like what happens once unit testing is done and once developer will deploy the code to the testing environment, then developer will come to you to give a demo, like what he has developed. So in that scenario, both developer and you as a tester, you both will test the same thing. Just a high level testing, you both will do. Developer will do the testing in front of you and he will show you like this is what we have developed and this is how it is working. So he will explain you based on his knowledge and you will see that based on your understanding. And as a tester, if you found like this is not is developed as per the requirement or there is some thing is missing or some problem is there, immediately you will notify the developer. So this is a buddy testing. Just after deployment, developer will come to you to give you a demo what he has developed. So some of the project this happens and some of the project it doesn't happen. Mostly in agile methodology this happens. Developer will come to you for demo, but some of the project doesn't follow this approach. Means they just simply deploy and will tell you test the application. So it is not a required thing to do. Even this should be mandatory. It totally depends on the project. If they make it mandatory, then developer has to give you a demo. If it is not mandatory, then he will not give you any demo. So in buddy testing, basically a tester and developer both test this test the model that has been developed by the developer. One more type of ad hoc testing is pair testing. In this testing, two testers work together where one execute the test case and on other documents. Like, let's suppose the first scenario I have given. Randomly, due to some scenario, due to some problem, due to some server downing problem, or due to some wrong deployment, functionality is not working, then that deployment is removed. Now you are doing ad hoc testing. So in that case, what will happen? One tester will do the execution and another one will sit and he will document everything. And document everything means he will note down all the sections name and he will just write like this is fine, this is fine, this is fine. Or is there any problem? Then he will write in front of that section like this section is not performing correctly. This is the problem. And based on that, you have to raise a defect. So one person is doing execution, and other one is documenting parallelly, so that it's there should not be all the load. Like one person should not take all the load. It should be shared among the two testers. One person cannot taste any and at the same time can document. It will take more time. So both things can be done parallelly. So that comes under pair testing. And one more is monkey testing. You know monkey jumping from one tree to another tree randomly. Same thing happens here also. In this type of testing, a tester performs the testing randomly, intending to break the system. Randomly, you will test. Right now you are on product search, then you go to that cart section, then you go to the wish list, then you go to the different section. Randomly you are clicking on any link, you are going to sign up, you are login, you are clicking on any link, you are entering any value. Randomly means you are doing testing and at a very high speed, just to check, due to this random testing your application, means your application is able to take the load or not, or it is getting break, or it is showing some different functionality, or there is a bug. Monkey testing is again comes under black box, in which tester provide random inputs and applies actions. Like there is a username and password. So randomly you are typing any word on the keyword. Randomly you are typing just to check whether your application is getting hanged, or it is, or some weird behavior the application is showing. Just to check that one. This helps to evaluate whether the system crashes when given such unexpected input. Like here, if I write, this is a random input, right? But I am doing intentionally just to check whether the application is getting crashed or hanged due to this behavior. Like any public user, he can do this activity, right? He can do this activity if it is available in public. So we have to also ensure our systems should take this kind of situation, can handle this kind of situation. So that comes under monkey testing. Here inputs can be data that is entered in the application, or clicking a button for the next action, or clicking on a link to navigate to another. Anything that you are performing randomly, one place to another place. So that is known as monkey testing. Monkey also do the same thing. So based on that concept, this has been named as monkey testing. Okay. So monkey testing done. Then first there is a first testing. I'm explaining all this because nowadays they are asking about. We do not do all this kind of testing, but they just want to know that do you have the concept. So basically, first testing is do for the is it basically belongs to the security testing that discovers coding errors and security loopholes in the software operating system or the network. Basically, the first testing is related to security testing. It involves inputting massive amount of random data called fuzz to the software being tested to make it crash or break through its defenses. In simple terms, large amount of unexpected random inputs are fed into the system, which might lead to the unexpected results. That is the crashing or breaking of the system. So first testing basically comes under security level testing, where we are checking loopholes in the in security level, operating system, network level. On this level, we try to find the loopholes. No one can do, anyone cannot do monkey testing. He should have the knowledge of operating system, about the networks, about the security. Then only he can do the first testing. Okay. So this also comes under ad hoc testing. So there are four different types of ad hoc testing: buddy, pair, monkey, and fudge. Okay. You just need to explain the word term. 1 second. First testing doesn't comes under ad hoc. This is different. Only three. These three. Buddy, pair, and monkey comes under ad hoc testing. This doesn't comes under ad hoc testing. Next is cross browser testing. Cross browser testing means is a non-functional type of testing where this helps ensures that our website or our application works as expected in various browsers. Like you are testing same thing, same application, same functionality, but in different browsers. Chrome, Firefox, Mozilla, uh, Edge, Internet Explorer, Safari, Opera. Same application you are opening on different browsers and you are doing the same testing. This is known as cross browser testing. That means same thing you are verifying in your application in different browsers. Just to check the application is behaving in the same way in different browsers or not. Okay, so this is known as cross browser testing. You just need to know the concept. All testing you cannot do. Next one is sanity testing. Sanity testing as a test execution which is done to test such implement each implementation of its impact, but not thoroughly or in depth. That means a very high level testing comes under sanity testing. Smoke testing is a software testing techniques performed post software build to verify the critical functionality of the software is working or not. Sanity testing is a high level testing that is done on a very high level, and smoke testing is done to check any critical functionality of the application is working fine or not. The main purpose of smoke testing is to reject an application with defect so that QA team doesn't waste time testing broken software application. If I give you a scenario like in first sprint, sign up and login functionality is developed, you have tested. In the second sprint, new functionality will be developed that we already know. But what we will do before starting testing the new functionality or the new section in the next sprint, we will do a high level testing on sign up and login functionality. When when the new functionality code is added, then we will just check whether sign in and login functionality is working or is it getting affected due to the new code or new section has been implemented. If both are working, then we will proceed and we will check the new functionality. We will test the new functionality. Or if it is not working, then immediately we will say the build, the deployment that you have done is affecting the previously developed functionality that is sign in and login. So you have to check your build and please fix it. Then only we will proceed and we will test the new functionality. So in this way, we do not waste our time. If the build is incorrect, that is affecting previously developed functionality, then we do not consider that build as correct. We reject that. So that comes under smoke testing. So smoke testing we do in every sprint. In every sprint, first activity that we do is the smoke testing. Now there are some differences. Smoke testing is performed to ascertain that the critical functionality of the program is working fine, and sanity testing is to check the new functionality or bug has been fixed. Smoke testing is done on previous functionality, and sanity testing is done on new functionality or any bug that has been raised is fixed or not. The objective of this testing is to verify stability of the system in order to proceed with more rigorous testing. And this objective is to verify the rationality of the system in order to proceed with more rigorous testing. This testing is performed by developers or tester, and this testing is usually performed by the testers. Smoke testing is usually documented or scripted. Sanity testing is not documented or scripted. The meaning is smoke testing test cases we generally write, but for sanity testing we do not write any test case. Smoke testing is a subset of acceptance testing, and it is a subset of regression testing. That means in regression testing we do sanity testing, and in acceptance testing we do smoke testing. Smoke testing exercises the entire system from end to end, but sanity testing is done on a particular component of the system, like any particular section. We do smoke sanity testing just to check whether this particular section is working fine or not. But smoke testing we do to check the entire end-to-end application. That is why it is generally known as general health checkup, and it is known as specialized health checkup. General health checkup means we are every sections we are testing on a very high level, not in a detail, but on a very high level. We are testing each and every sections of the application. But sanity testing we only do on a particular module of the application. That is why it is a specialized health checkup, the general term. So if I tell you the definition, you can say smoke testing is done on the entire system from end to end on a very high level to ensure the critical functionalities of the application is working fine. And sanity testing is a specialized testing where we do this kind of testing only on a particular section of the application to ensure that requirement of that section is working fine, it is not exhibiting any bug. This is the simple definition of smoke testing and sanity testing. Smoke testing for we write smoke test cases for smoke testing. We do not write test cases for sanity testing. These are the differences that you can say whenever you have been asked. Okay. So these are different testings, different types of testing that I have discussed that you can expect an interview. They are asking ad hoc testing, sanity, smoke, bunker testing, first testing. And apart from that, the rest of the testings I've already discussed in the project classes. Black box testing, white box testing already done. Mostly I have covered unit testing, integration testing, system testing, user acceptance testing, alpha, beta, gamma, all the different testings I have explained. Just always try to explain in a simple word. Don't recite the definition just tell them. Just tell them the meaning. You can note down how I'm explaining. You can replay the rewatch the recording. You can note down how I'm telling you on a very simple language. They don't want to hear the definition. They want to hear the understanding. So just tell them your understanding. And they don't want if they ask smoke testing and sanity testing. So it is not like you have to tell 10 points. No, just tell them 3, 4 points, 5 points. That is enough. 10 points, 15 points. You don't need to tell. Whatever you remember, just tell them. But try to cover the important one. Like here, just tell them the definition, who done this, who did this, what we generally do here. We do not document, we document. All these are the important points. Okay, so with that, this part is done. One part is left, that is the interview question document I have to provide. To that, I will provide 30 questions I have already noted down, 20 more I need to note down with explanation. Wherever it is required, I have to provide the explanation I am giving. And wherever that I have already explained in the classes that I'm not writing. So I will provide you the entire document by Saturday, the interview questions one. And these documents I will provide you just after this class. So with that, this second part will be covered. And from next week, database part will be started. Okay. So that's all. If anything to discuss or You can ask or we can drop it.
So, sir, if there are any questions, like if I'll go through all the videos, so I can
Mhm.
ask you later on also, no?
You can personally ask me.
Okay,
You can ping me on WhatsApp and we can discuss over there.
okay,
Okay.
thank you.
Then thank you everyone. You can drop off now.